Okay, this video is another in the series for Math 1073 for UTSA. I have the file for Module 0.4 Video Lecture Class Examples pulled up, and we'll just go through and work out these examples. So the first one says, for the following exercises, first find the slope of a line given 2 points, and then find the equation of the line. So for part A, we've got two ordered pairs, and we're going to find the slope and then the equation of the line. So remember that the slope m is rise over run. There's lots of ways to write this. The more technical notation, which you may have seen before, this will be delta y over delta x. That's very technical. That means change in y over change in x. If you've ever watched like a NASA or a Tesla, not Tesla, a NASA or a, what do they even call it? It's not Tesla. Virgin Galactic, is that right? I don't remember. Anyway, SpaceX, that's what it's, SpaceX. If you ever watch one of those, they'll have something like the delta V. That's the change in velocity. It's the acceleration, basically. It's a measure of change in velocity, a measure of g-forces in some sense. Anyway, it's very technical. Let's avoid that for now. You'll use that later in calculus. Let's call this y2 minus y1 over x2 minus x1. So we'll call this point 2, and we'll call this point 1, because that's the order that they're given in. If you were to change the labels and call the first one 5, 4, you call that point 2 and call the other one point 1, that doesn't affect the result that you get. It's just a change in the name, change in the labeling. So I'm going to plug in those numbers into y2 is the y coordinate of the second point, so 9. And y1 is the y coordinate of the first point, so 4. So the numerator will be 9 minus 4. 9 minus 4 over x2 is the x coordinate of the second point, which is 7, and x1 is the x coordinate of the first point, which is 5. So I'll have 7 minus 5. Okay, so I get 5 over 2. So that is the slope of the line going through those 2 points, 5 over 2. So to find the equation for that line, there's two basic ways. I think I'll do one version with this example and the other version with the other example. So if you use the point slope form for a line, it looks like this: y equals m times x minus x1 plus y1. Okay, and again, it doesn't matter which point you call point 1 or point 2. That won't affect the result. So there's a couple of ways to work this problem out, and they all get the same result. So what I'm going to do is plug in the slope that I found in for m, and then I'm going to plug in the coordinates for point 1 into x1 and y1. And that will basically give me the equation of the line. I just plug in the numbers into the formula. So y equals 5 over 2, it's the slope, times, and notice that this x here does not have a little subscript 1, it's just x. That's because it's the variable in the equation that will be my answer. x1 is the first coordinate, the x coordinate of the first point. Okay, that's why it has the subscript 1, because it comes from point 1. So x minus 5 plus 4. Okay, and that's an answer. The problem doesn't say, it just says it says find the equation of the line. So that's an answer. That's an equation, and it comes from the line. What we could do, and sometimes we will need to do this, other times we will not need to do this. It depends on the context. I'm going to distribute the slope onto the x and the negative 5. So this equals 5 over 2x minus 25 over 2. Okay, plus 4, right? Which I'll write as 4 over 1, because that's going to help me combine the two numbers into 1. I'm going to need a common denominator, so I need to double the top and bottom of this one so it has the right denominator. So then I'll have 5 over 2 x. I want to add these together. I have negative 25 plus 8, so I get negative 17 minus 17 over 2. So this one is called the slope-intercept form. So this one's fine. If the problem doesn't tell you which format to use, then that's okay. In a WebWork problem, you'll probably be told which format to use. If you put this in to WebWork and the system says something about formatting. Maybe it wants this format. So try that if that happens. Okay, again, this is called the point slope form. And this one is called the slope intercept form. Okay, so next example, we're going to do basically the same process, but for this one, we will not use the point slope form at all. We'll use the slope intercept form from the beginning. Well, not the beginning, but you'll see. So we need the slope. So again, we'll call let's call this point 2 and this point 1. Well, let's mix it up. It doesn't matter what order we do things in as far as labeling. So M, this will be rise over run, which I'm writing every time, but you don't need to do that. I'm just writing it so that it's clear as we go along. So I'm going to say, well, this is a y2 minus y1 over x2 minus x1. Okay. So that's going to equal, well, y2 is this one, because I called this point 2, and y1 is this one. Okay, so 2 minus negative 7. Whenever you have some negative coordinates, be sure that you don't lose track of the minus signs that are needed. So then x2 minus x1. So this will be negative 3 minus 4. Okay, so this will be, what is that, 9 over negative 7, or if we want, negative 9 over 7. Okay. So now let's, that's the slope. Let's find the equation for the line. And I'm going to start with the slope intercept form, y equals mx plus b. Okay. So, of course, m is the slope that we found, 9 over 7, rather negative 9 over 7. I'll go ahead and plug that in. And the next step might not be so clear because this form doesn't have an x1 and a y1. So it's not, maybe not obvious what to do next. So remember that the equation for a line should be an equation that describes which ordered pairs lie in the graph of the line, right? Any xy pair of numbers that plugs into the equation and fits, makes the equation true, hey, that's a point on the line. So if I take either of these points and plug it in, it should make the equation true. So what I can do is go ahead and pick one, plug it in, and then find out what number b makes that true. And then that will also work for the other point. That will complete the line, essentially. So I can use one of these points to plug in. Kind of like over here, it's just that this formula tells you where to put them in. And it tells you to use the one you called point 1. So it's maybe a little bit easier to use, which is why I started with that one. Here, we have to know what to do with the ordered pair. It's not that it's overly difficult. Maybe it's 2% harder because you have to know what to do. But it's just another way to do it. Anyway, I'm going to pick point 1 to plug in. So I'll plug in negative 7 for y and 4 for x. Okay? So negative 7 equals negative 9 over 7 times 4 plus b. And I'll try to not make that b look like a 6. So I'm going to have negative 7 equals negative 36 over 7 plus b. Okay. Now, at this point, in a previous video, I said I like to clear fractions when I'm solving an equation just because that makes things easier. In this case, I'm not going to do that because the variable does not have a fraction. I'm just going to add 36 over 7 to both sides. And I am running out of room a little bit, so I'm going to start a new column up here. So I'm going to have 36 over 7 minus 7 equals b. So we almost have our number b, but I need to get a single fraction, not a difference of two numbers. I'm going to think of this 7 as being 7 over 1. That might help me a little bit in figuring out what the total is. So I need a common denominator, right? These denominators need to both be 7, right? So this fraction, I need to multiply top and bottom by 7 to get the denominators to match. So times 7 there and times 7 there. Okay. So I'm going to have 36 minus 49 all over 7 equals b. So I get, was it negative 13? Negative 13 over 7 equals b. So my resulting equation is y equals negative 9 over 7x minus 13 over 7. And if I want to check that I've got the right answer, one way to do that is to take the other point, the one that I didn't use over here, like I never used the negative 3 and the 2, take that ordered pair and plug it in, plug in negative 3 for x, plug in 2 for y, and make sure it solves the equation. And if it does, oh, well, then I did it right, because that was the point I didn't use to find out what b was. If I made a mistake, plugging in negative 3 comma 2 won't work. I'll get a false equation, right? So that's a way to check my answer. I'm not going to bother doing that here just because of time, but that is what if you wanted to check, you could do that. So what does the next problem say? For the following exercises, find the equation of a linear given the slope in 1 point. I think they mean line. I think that might be a typo. Yeah. Okay. I think they probably changed the wording, and the grammar they had been using, linear, made sense. Maybe it was like find the linear equation, and they decided to switch it around, and they forgot to take that out. Anyway, so the slope in 1 point. So basically, what both of these are doing is it's kind of like asking us to do this half of the problem and say, oh, this half we've already done. Oops, this half we've already done that for you. You don't have to write that out. We've just given you n. So it's really maybe an easier version of what we just did. Okay, so if it's easier, let's get started. So m equals -2, and we have the order pair negative 3, comma 6. So I'm going to do this first one using the point slope form for a line, and then we'll do the other one using the slope intercept form. So y equals mx plus b. I'm writing the form every time I use this, not merely for the benefit of you guys seeing it again, but I think when you are working these problems out for web work, you should write the formula every time you use it. That way, when you go to do a benchmark or in a later course, maybe in the spring for 1093 or later for Cal 1, Cal 2, so forth, you just know these formulas because you've been using them consistently. So I'm going to go ahead and plug in -2 for m. Okay. And I guess I could be a little more efficient with this, but I'm not going to worry about efficiency necessarily. I'd rather be a little inefficient and show the steps clearly. So, oh, I'm sorry, that's right. I said I was going to use the point slope form. That's okay. We'll use point slope for this other one. That's okay. So slope intercept, fine. But a small error doesn't matter. So I'm going to plug in the ordered pair into the equation to find out what value b should be in order for this to work. So I'll plug in 6 for y and -3 for x. I'm running short on space, so I'll start a new column up here. So I have 6 equals 6 plus b. And conveniently enough, my b looks like a 6. So I'm going to subtract 6 on both sides to get b by itself. So b equals 0 in this case. That's convenient. Okay, so y equals -2x since b is 0. I could write plus 0, but I don't need to. Just leave it like that. Okay. So let's do the other example and actually use the point slope form. So y equals m times x minus x1 plus y1. And I just plug in the numbers. Plug in 3 for m, plug in 2 for x1, plug in -4 for y1. So I will have 3 times x minus 2 plus -4. So distributing, I'll get 3x minus 6 minus 4. Running out of space here, so I get y equals 3x minus 10. Okay. One thing I might want to point out, yeah, I actually want to redo this one with the point slope form, so let's do that. So m is -2 and -3, 6. Okay, let's just do it here. I'll change colors as well. So redo, is this 2b, I believe? No, 2a. 2a. Yeah, 2a. Okay. Come on, zoom in. So m equals -2, and then the ordered pair is -3,6. Okay. Why do I want to do that? So the point slope form for a line is like this, and in fact, I should probably change the stylus to be smaller so everything fits nicely. Okay, I want to do this because we have a negative here, and I want to make sure it's clear what happens when you have a negative in the x-coordinate with this format. So I'll plug in -2 for m, x minus -3 plus 6. And notice that I have a double negative here. Okay, so one step at a time, this is -2 times x plus 3. Double negative means you have a plus. Then I distribute the -2, so -2x minus 6, right? -2 times 3 makes -6 plus 6. And of course, am I running into that space? A little bit. So then I get -2x plus 0, and that 6 looks like a b. So -2x. The same answer we got before, but I just wanted to point out what happens when you have a double negative. And then, of course, we're still multiplying by a negative. It's really a triple negative. So we end up with a -6 after distributing, okay? Because there's really a triple negative at play there. Okay. So, next example. For the following exercises, find the equation of a line using the given graph. Okay. So, it's a little blocky. Oh, well. I'm going to continue this line. I'm going to pretend that it was actually longer than what it's showing me. Let's do this. That'll work. Okay. Sometimes when I hit the undo button, it actually does more than I really want. So I'm just making the graph a little bit longer. That's not essential, but I just thought it would help out a little bit. Okay, so looking at this graph, I can see that this place where the graph hits the x-axis is the ordered pair 2, 0. And I can see that this place where the graph hits the y-axis is 0, 2. So I can use that, much like the first problem, and do rise over run, find the slope. I could also look at the graph and say, well, let me pick those 2 points here and here and count. If I were to move along the graph from that point to that point, okay, how would my rise change? Well, I'd have to move down 2 units and then over 2 units. So my rise over my run would be -2 because I'd move down 2 over 2 because I moved over 2. So -1. Of course, if I do the formula y2 minus y1 all over x2 minus x1 with these 2 ordered pairs, I get the same number. But when you have a graph, you don't necessarily have to use the formula. If you can tell by looking, just make rise over run. Okay. Now, looking at this graph, I can tell, oh, I know the y-intercept. It's 2, right? That's where the graph touches the y-axis. So I know that this is my m in the slope-intercept form for a line. And +2, this is my b. That's the slope-intercept, right? In the format y equals mx plus b, this is called the slope-intercept form, right? Well, that's because the slope is here and the intercept is there, okay? So just without writing too much, obviously you can do this arithmetic in your head. That's not very difficult. Just from looking at the graph, sometimes you can just say what the equation is. Not always, sometimes it's a little bit harder, but in this case, we probably could have. So this is -1 times x plus 2, or if I want, -x plus 2 is the equation for that graph, or an equation for that graph. Okay, let's go to the other one. So for b, I can look at it and say, well, I know what the intercept is, right? B is -2. In fact, let's do it like this. B equals -2. That's the y-intercept. What's the slope? Well, I can see I have this intercept here, and I have this intercept here. This is the ordered pair 1, 0, right? So if I move from this point to this point, if I travel along the graph, how will my vertical change? Well, I'll move up by 2 and over by 1. So my rise over run, okay, I'm going to rise 2 and run 1. I get 2, okay? So that means that I'm going to have y equals mx plus b. Well, my slope is 2, and my intercept is -2. There we go. I can write the answer without really doing much arithmetic. Obviously, 2 over 1 is 2 is not difficult arithmetic. And once you get used to doing this, you can do all this in your head. You don't have to write this down separately. And you just write down the answer. After you've done this a few times, you get used to, what are the important values I'm looking for? And when the numbers aren't hard, then you can do it in your head. And if you're, you don't want to make mistakes, or you're worried about if you're worried about underestimating the complexity, well, then write it out and, make sure you're not making a mistake. Okay. What about the next one? Is this the last one? No, 2 more. For the following exercise, graph the linear equation by plotting points. Okay, so by plotting points, to me, that's the operative term here. I want to plot points. So I'm going to make a t-table, pick some x values, and then let's make that a little bit heavier. So I've got a column for x values and a column for y values. And I could just pick numbers randomly, like x is 0, 1, 2, 3. That would work. But because of this fraction, and I don't want to try to graph with fractions if I can avoid it, I'm going to pick x values that are multiples of 3 so that when I plug them in, I don't have fractions as a result. So I'm going to go, how big is my graph? It's like 20 by 20. It's 10 in all directions, I think. So I'm going to go with -6, -3, 0, 3, 6. 5 points should be plenty. 2 points define a line, so 5 rather. 5 points should be plenty. So I'm going to take the -6 and plug it in for x and see what I get as a result, okay? So the y value, this will be -2. I guess I'll zoom in here a little bit. -2/3 times -6 plus 2. And you can think of this, if you want, as being 12 over 3. That'll work. I prefer to avoid larger numbers, so I'd like to reduce the 3 and the 6 first. This is kind of like having a -6 over 1. And so this is on top and this is on bottom, so you can reduce them, right? So I'm going to go, this cancels to 1, this cancels to 2. Okay, so I have -2 times -2 plus 2. I have 4 plus 2. So I get 6. Okay. And we'll go plot that in a moment. I just want to go get these values first. So -3, so -2/3 times -3 plus 2. Cancellation. Again, before we cancel, this 3 here, I think that's being 3 over 1. So I can cancel that 1, cancel that 1. So I have -2 times -1, 2 plus 2. So we get 4, all right? If I plug in 0, I will have -2/3 times 0 plus 2. Anything times 0 is 0, so I have 0 plus 2, so I get 2. And if I plug in 3, -2/3 times 3 plus 2, I can cancel this 3 with that 3, and I get -2 plus 2. I get 0. Then I can plug in 6. So then I can reduce. This reduces as 1 and as 2. So I get -4 plus 2. So I get -2. So now I can go over and plot each of these pairs. I can plot -6 with 6, -3 with 4, 0 with 2, 3 with 0, and 6 with -2. Okay, so let's go do that. So over here, and I guess I will use kind of a bright color so it stands out. So -6, 6, that's my first ordered pair. So each of these units is like 1 unit. So 1, 2, 3, 4, 5. -6 is over here. 1, 2, 3, 4, 5, 6. +6 is there. So there's my point. And then we had -3, 4. Struggling with the interface there. So -3, 4. So like right there. And then we had 0, 2. So right there. Then we had 3, 0. And we had 6, -2. Okay. You can see it makes a straight line pattern, right? So if I make a straight line here, I can connect them. And I can, it's off by a little bit, so I'll fix it. There we go. That is the line. And I typically don't put arrows at the ends of these. Sometimes I do. Sometimes I want to avoid cluttering the graph, but let's go ahead and do it with that one. So that's that example. So next, we'll be doing a similar question, but it's not quite the same. It doesn't ask us to go by plotting. This says for the following exercise, graph the linear equation using the y-intercept and slope. Okay, so if we look at the format y equals mx plus b, and I guess I'll change colors again. Y equals mx plus b, that means that the y-intercept is -1 and the slope is 3/5. Okay, so this is the rise over run. This is where the graph hits the y-axis. So I can go over to where y is -1 on the axis and mark a point down because that's going to be a point on the graph. So -1, bam, there's a point on the graph. Okay, we don't need a table for this necessarily. If I look at the slope, the rise over run is 3/5. 3/5. 3/5 is the rise over run. So if I want a second point, I can run horizontally by 5 and rise by 3, or run in the negative direction by 5 and then fall in the vertical direction by 3. That would also work. But I'll go in the positive direction. So if we go over 5, we go up 3. So if we go over 1, 2, 3, 4, 5, and then go up 3. From here, 1, 2, 3. So I'll put my point there. Okay. So instead of plotting out points, I only need 2 points to make a line. You know, at a minimum, you got to have 2. And if I know the y-intercept and I know the slope, well, I can work out the line based upon that. And I'm not going to spend all day trying to make this perfect, just half the day. There we go. Perfect. So there is my line using the slope and the y-intercept. And that's the last example for this video.